So what we're going to be looking at in this video is solving systems of linear equations using graphing. So just like we were talking about in the previous video, we run into the problem that a lot of the time equations aren't in the slope y-intercept form. And we need to get them into that form so that we can graph them easily if you're going to be plotting them on a grid. So for example, these could be two equations that we would see. 5x plus 2y is equal to 8, and x minus y is equal to 3. Okay, those are two different equations. So what we're going to try and do is get y by itself for each of these. I'm going to start with this one. So to get the y by itself, we need to move the stuff that's around the y to the other side of the equation. So we need to say minus 5x minus 5x. So then we have 2y is equal to 8 minus 5x. And then we just need to get rid of the 2 that's in front of the y. So we're going to divide by 2. That gets rid of the 2 in front of the y. So we have y is equal to 4 minus 5 over 2x, right? Because 8 over 2 is 4, and then 5 over 2 we can't really simplify any further. Now let's look at this one. How do we get the y by itself? Well, we need to move the x over to the other side, so we're going to say minus x. That cancels those out. So then we have negative y is equal to 3 minus x. We still need to get the y by itself. So we have a little imaginary 1 in there, right? If you have a negative variable, there's a little imaginary 1. So we are going to divide by negative 1, divide by negative 1, divide by negative 1. So that cancels out the negative. So we have y is equal to negative 3, because it's 3 over negative 1, so positive over a negative is a negative. Then we have negative x over negative 1, negative over negative is a positive, so we have plus x. So now what we can do is we can actually graph these, because if we write them in slope y-intercept form, we have y is equal to negative 5 over 2x plus 4. So our slope would be negative 5 over 2, and our y-intercept would be 4. And this one would be y is equal to x minus 3, where our slope is just 1, and our y-intercept is negative 3. So we could plot these on a grid, or what I did is I just plotted them on an online graphing tool. So as you can see, I have the two equations. I have y is equal to negative 5 over 2x plus 4, and I have y is equal to x minus 3. And when I graph them, I see that there's a point where they cross right at 2, negative 1. The point that we found was the point 2, negative 1. So because using graphing to figure out where the lines cross isn't the most exact thing, right? We're just looking at a graph. Especially if you plot the points, it's kind of difficult to tell whether it's an exact point or if it's just off of the axes. We need to test this point in both of these original equations to see if it's an actual point on the line. So I'm going to test the first equation we looked at first. So what I'm going to do is, because this is the x and the y value, I'm going to say 5x plus 2y is equal to 8. I'm going to sub in the x and the y value. So it'd be 5 times 2 plus 2 times negative 1 is equal to 8. So I'd have 10 minus 2 is equal to 8. So I have 8 equals 8. So yeah, that's that. This is a point when you graph this function. So what about the next one? We have x minus y is equal to 3. So I'm going to sub in these values. I'm going to say 2 minus 1, or minus, sorry, negative 1, is equal to 3. So I'd have, because it's minusing a negative, I'd have 2 plus 1 is equal to 3, or 3 is equal to 3. So that also checks out. So this is a point where both of these lines cross, because it is a point on both of these lines. So that's an important check that we need to do.